Now we are starting question number 2 for this topic of kinematic. A train starts from rest at a station A and travels in a straight line towards B station. When it comes to rest, the train moves with a constant acceleration of 0.025 meter per second square for the first 600 seconds, then with constant speed for the next 2600 seconds, and finally it with a constant deceleration of 0.0375 meters per second square. Part 1. Find the total time taken for the train to travel from A to B. Part 2. Sketch the velocity time graph for the journey and find the total distance in AB. Third, the speed of the train t seconds after leaving A is 7.5 meters per second. State the possible values of t here. Since it is A to B, it travels. At A, its initial speed is 0, and then it stops at B, its speed is 0. Where from A to C, the first part, it is going to cover 600 seconds with an acceleration of 0.025 meters per second square. Then from C to D, it moves with a constant speed, and time taken is 2600 seconds. And then from D to B, there is retardation of 0.0375 meters per second square, and it finally comes to rest at B there. And we are going to calculate first the total time taken from this. Find the total time taken for the train to travel from A to B. Now, we know that acceleration first we will calculate the velocity. U is 0 there, time is 600 seconds, and so it will be V is equal to U plus AT, where V we are going to find out. U is 0 there, acceleration is 0.025 into time is 600. So that is after calculation, it is going to be equal to 15 meter per second. So at this point C, its speed is 15 meters per second. Then it moves with the same speed there till D with 2600 seconds, and then from D to B, it decelerates with 0.0375 meters per second square. So from D to B, we know that the speed at that moment is 15 meter per second. Final speed is 0 there. Deceleration is minus 0.0375 meter per second square. So V is equal to U plus AT. V is equal to 0 there. U is 15 minus 0.0375 into time t there. So time t is there 15 over 0.0375, and that is being calculated equal to 400. So total time for this journey is equal to 600 plus 2600 plus 400, and that thing is equal to 3600 seconds it is going to take in this whole journey from A to B. Then in the second part, you are going to draw the graph between time and velocity there. So let's say this is velocity, which is in meter per second, and that is time there, which is in seconds. So for the first part, it is accelerated up till 400, so 600, and it is with acceleration of 0.025. Then for the next 1600, it is this position, and it is going to take the distance between these two as 2600 seconds. So this is going to be equal to 600 plus 26, so that is equal to 3200. And then it is going to have the retardation there for the last 400 seconds. So this will become 3600. So this is the velocity time graph for this curve there. And for the last part, they are asking in the third part, they say that find the speed when the time when its speed is 7.5 meters. So let's say this is the line where speed is 7.5. So there are two positions there. Let's say one is P and one is Q, where the speed of that particle is exactly equal to 7.5 there. Now we will calculate first for the time for P and then the second time for the Q there. Since for P position, the acceleration is already given to us in this part equal to 0.025 meters per second. So V is equal to U plus AT, where V is now 7.5, U is 0 there. Acceleration is 0.025 into time T1 there. Let's say it is T1. So T1 is basically equal to 7.5 over 0.025, which is equivalent to 300 seconds. So it is at the position P when the speed is 7.5, the time taken there is 300 seconds. Then at the point Q, here it is 3200 is the time and the speed is here 50. And at this position, the time is there unknown, but the speed there is 7.5. So the deceleration for that particle from this position to this point Q there is equal to minus 0.0375. So we can use the gradient formula there. So acceleration there is equal to V2 minus V1 over X2, sorry, T2 minus T1. Here acceleration is equal to 0.0375 and V2 is there 7.5 minus V1 there is 15 divided by time minus 3200. So This is going to be calculated equal to so it is equal to t minus 3200 is equal to 200. So t is equal to 3400 seconds. So second time when it will be having 7.5 meters per second speed, so time will be equal to 3400. So two timings are there. One is 300 seconds and the second one is 3400 seconds for this journey of train there.